784 using scientific notation. A lot of you know this, and it's a little bit of a shame. It's not done much in freshman science classes, but it will be done a lot in sophomore level science classes, or anytime you take a chemistry class. They spend a lot of time working with scientific notation. It will pop up a little bit in physics and other classes, but chemists are the one who like to use it the most. So here's a number, 2,100,000, and that's actually written in what we call standard form. The other way to write it is 2.1. We got to go 1, 2, 3, 4, 5, 6 spaces to the left. 2.1 times 10 to the 6th. And that is called scientific notation. So that's a large positive number, and the reason we use scientific notation is it's a lot easier to write than trying to write out all these zeros. They take forever, and it's easy to make mistakes. We just go 2.1 times 10 to the 6th. It's a little bit easier. Same thing, instead of saying 0.000000345, write 3.45, so it's always one number. Then the decimal point. And then the other numbers. And then it's times 10 to a number. In this case, we're going to go to the right. 1, 2, 3, 4, 5, 6. And since it's to the right, we put a negative 6. As we talked about previously with negative exponents, a lot of people confuse thinking this means a negative number. It doesn't. A times 10 to the negative 6 means a really small number. A times 10 to the 6 means a really big number, at least relative to a 1 or 2. So that's it. Just practice. So this is 4.3 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 5.1 times 10 to the negative 1, 2, 3. 1, 2, 2.3004 times 10 to the negative second. 2.1 times 10 to the 1, 2, 3 third. Now going the other way, a little trickier. Write 2, 1, 3, and then 1, 2, 3, 4, comma there. Erase the loops. 21, 300. 1, 2, 3. Yep, and I always double check just to make sure. 1, 2, 1, 2, 3, 4, 5, and we always put a 0.0 out front. Just habit. Kind of sets it off so it's easier to see, but I think it's just habit for most teachers. 1, 2, 3, 4. Yep, that's negative 5. 0.91. 1. Yep. And 1. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So practice. Make sure you know what you're doing. So how's this apply to the unit? Well, those times 10 to the something are actually exponents. So if we were multiplying them, what we could easily do is 3.3 times 1.0 is 3.3. And then times 10 to the third times 10 to the fifth is times 10 to the 8th. How do we get 10 to the 8th? 10 to the third times 10 to the 5th. Add the exponents. So here we have 8.2 times 9.1. Well, that's a little bit much for me to do without a calculator, but I'll try anyway. 8.2, 9.1. So that's 74.62 times 10, add them to the negative 5th. Now, the decimal's not in the right spot, so we have to go to the left one. 7.462. And if we're going left, You have to add 1 to this, which means it's actually to the negative 4th. And let's see if I did that right. Something tells me I didn't. 1, 2, 3, 4, 5. 1, 2, 3, 4. Yes, I did. So those are equivalent. That's very confusing. You can always check with your calculator. And now the divisions. 4.2 divided by 2.1 is 2 times 10. 3 minus 2 is 1 to the first. And over here, 3.1 divided by 9.3 is actually 0.3 repeating. So I'm just going to go with 0.3. And 5 minus negative 3 is 8. 10 to the 5th over 10 to the negative 3rd equals 10 to the 5 minus negative 3 equals 10 to the 8th. And previously, we had this situation up here where we had a 74.62, moved it left, and we actually got 1 bigger. So now we'll remember that. 0.3, we got to move it 1 to the left, and it'll get bigger. So, practice writing these in scientific notation and standard notation. You might want to stop the video now and try these yourself. That's about it. Hope those worked out for you. If not, write some up of your own and practice them. You can always go online and write scientific notation problems, and they'll pop up nice and easy for you. Good luck.